Okay, question number 2 says, is this a redox reaction? Give your evidence. So several reactions are given to us and it asks us to identify if it is redox reaction or not. So you know what is the properties of the redox reaction. If the oxygen is transferred, if the hydrogen is transferred, and if the electron is transferred, you have oxidation reduction of equation. Otherwise, you don't have that one. So let's look at the first one. First one, you have magnesium at the left side, and the right side it becomes MgO. It means it has gained the electron and it is oxidized. And at the left side, you have carbon dioxide. At the right side, you have carbon. So it means it has lost the electron and it is reduced. So this one is a redox reaction. So the evidence is transfer of oxygen. Okay. So let's see for the next one. Can you identify if it is oxidation reduction reaction or not? Okay, so for the previous one, look what happened. This oxygen from the carbon has gone for the magnesium. So the oxygen transfers from the carbon to magnesium. This is oxidation and reduction reaction. What about part B? So the oxygen transferred from the silicon to the carbon. So you can see silicon has lost the oxygen here and carbon has gained the oxygen here. So this one is also redox reaction. Okay, so for part C, you have NaOH reacts with HCl, becomes NaCl and H2O. So you have oxygen here in the NaOH, but is it transferred to the chlorine? If you look at the other side, the chlorine has not gained the oxygen. Also, you have hydrogen here in NaOH, but is it transferred to chlorine again? If you look at the other side, you can see it's not gained the oxygen. So the oxygen is not transferred to the chlorine. No, based on the transfer of the hydrogen, same thing happens. In NaOH, you have hydrogen, but it has not transferred to the chlorine because at the other side, you don't have hydrogen with the chlorine. And at the same time, here for HCl, you have hydrogen, but the hydrogen has not transferred to the Na because you cannot see any hydrogen around the Na. So it means you don't have transfer of the oxygen, transfer of hydrogen here. So this is not a redox reaction. This is a specific type of the reaction, which we call it neutralization reaction. If you remember, in the first video which I have made for this lesson, we said this is base and this one is acid. So what you have here is neutralization reaction. When the acid and base reacts with each other, they neutralize each other. The product on the other side would be salt, in this case NaCl and water. So this is a specific type of the reaction which is neutralization reaction. So this one is not a redox reaction. Let's move on to the next one, part D. We have iron at the left side, but what happens to it? If you look at the iron at the other side, it means it has gained the oxygen. It means the oxygen is transferred from the copper trioxide to the iron. And you can see on the other side, the copper has lost the oxygen. So you have transferred of oxygen between the reactants. So this is a redox reaction. And for the last one, you have carbon at the reactant side, and the product side, you have carbon monoxide. It means the oxygen has transferred to the carbon, and you can see this lead here has lost the oxygen. So the oxygen is transferred from PbO, lead trioxide, to the carbon. So on the other side, you can see the carbon has gained the oxygen and the lead has lost the oxygen. So this one is also a redox reaction. So all of these are redox reaction except part C, which is neutralization reaction. The question number 3 is a very good question. All reactions in which electron transfer take place are redox reactions. This diagram shows the electron transfer during one redox reaction. So what do you have here? Here you have the magnesium atom, And the electron configuration of the magnesium atom is written here is 2, 8, 2. You have 2 electrons in the first energy layer, 8 in the second one, and in the valence layer you have 2 electrons. And what is written at the right side, you have 2 chlorine atom. So this is the chlorine atom. Each chlorine atom has 17 electrons. Its electron configuration is like this, 2, 8, 7. So in the valence layer you have 7 electrons. Magnesium atom is metal. Chlorine atoms are non-metal. You know, when the metal and non-metal react with each other, the electron transfers from metal to non-metal. It's shown here. Okay, magnesium must lose how many electrons? It must lose 2 electrons because it has 2 valence electrons. And each chlorine atom, they have 7 electrons. If they want to become octet, each one of them must gain 1 electron. So the electron transfer from magnesium atom to chlorine atom here. Now let's answer the questions. It says, what is the product of this reaction? So what is the product of this reaction when the magnesium gives 2 electrons to 2 chlorine atoms?
Magnesium chloride.
Exactly, it's magnesium chloride. Okay, so it's MgCl2, magnesium chloride. Okay, it says write a balance equation for the full reaction. Part I says, okay, balance equation for full reaction. So what do you have at the beginning? Right here at the top. At the beginning, you had 1 magnesium and 2 chlorine atom. When they react with each other, they form ionic compound. The ionic compound is magnesium chloride, as you said. Okay, so this is part B. In part C, it says which element is being oxidized. Okay, which element is oxidized here? Which one has lost the oxygen?
Magnesium.
Exactly. Magnesium. And let's go to part D. It says which element is being reduced here? Which element? Chlorine, because it has gained the electron. So here in these equations that you have here, magnesium is oxidized and chlorine is reduced. Okay, so it's obvious magnesium has lost the electron, as you can see here in this picture, so it is oxidized. Chlorines have gained the electron, so as you can see in this picture, so they are reduced. Okay, C, second part, says write a half equation for oxidation. So what happens for oxidation? So I want to write oxidation half equation. So in oxidation half equation, magnesium has lost 2 electrons, so it becomes Mg2 plus. So magnesium becomes Mg2 plus and it loses 2 electrons. It's obvious from this picture. Magnesium has lost 2 electrons. When it loses 2 electrons, it becomes Mg2 plus. So this is oxidation half equation. And for reduction half equation, okay, so for reduction half equation, what do you had at the left side? You had 2 chlorine atom, as you can see here. So you have 2 chlorine atom. What do you have on the other side? You have 2 Cl minus. But you know, for the chlorine, you can write this one as Cl2. Okay, because we don't have separate chlorine atom, they are joined to each other, so always we have diatomic molecule of the chlorine. So for this one, instead of writing 2Cl, it's better to write Cl2. Okay, so we have 2 chlorine atom, but they are in the molecule. Okay, so how many electrons they gain? Each one of them has gained 1 electron, so it becomes plus 2 electrons. So this is reduction